हेलो माय डियर मैकेनिकल चैंपियंस, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? अपोने कीमे नाचेन येल्लवनारू तुवाड़ा कियाली. Please do join me fast. Myself Chandrasekhar, welcoming you all to this wonderful session on fluid mechanics. We will be discussing the formula revision along with the beautiful numerical practice from the fluid statics and kinematics in today's session. So the whole fluid mechanics is divided into two parts for your ISRO 2023 preparation. FM1 will be discussed today, statics as well as kinematics, and day after tomorrow at the same time on the same platform we will be having the discussion or revision of fluid dynamics. All right. Yes, Rakshit, good morning. Studu Thakur, Pejal, Namaskar, Adab, Suprabhat, good morning. Sat Sri Akal, Assalam Walaikum, Wanakam. Please get yourself settled down fast because we have too much to discuss in today's session and we will try to complete the whole discussion in next 1 hour. All right, so keep your pen and notebook handy. Try to write the important formula. Try to solve the questions which I will be providing you. So the more you participate, the more comfortable you become with the concept. Shall we start? Please do let me know if my audio and visual quality are fine. Those who are watching me live, please do respond through the comment section. So I also get motivated with your presence, with your energy level, with your love and affection. All right, so those who are meeting me for the very first time, this is my quick introduction. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience, exclusive experience of 10 years into teaching, guiding the students who are preparing for various competitive examinations. I have also cleared engineering services examination, worked in Steel Authority of India Limited for a couple of years, and I am quite comfortable in fluid mechanics, heat transfer, thermal engineering, as well as industrial engineering. All right. If you have anything to discuss regarding your preparation or regarding any of the subjects I have mentioned, you can always write me a mail to my official mail ID, or you can join me on the Telegram. Around 1500 students are already part of my Telegram channel, which is Mechanical by Chandrasekhar. So once you become part of my Telegram channel, you will be getting these many benefits. The link to join me on the Telegram is also given at the bottom of this screen. All right, so sit back, relax and enjoy this beautiful session. It is the combination of revision of the formula as well as some wonderful question practice, hand-picked questions. So which will make your preparation or which will help you to boost up your preparation and to score better in your ISRO exam. As you all know, ISRO is a golden chance for all the mechanical engineers. So one information before we start our session, on 23rd of July, there will be a national scholarship test for GATE exam. So please do not forget to participate in this scholarship test. And please prepare yourself before participating in the scholarship test, because based on your performance in the scholarship test, you will be able to avail up to 90% scholarship in our various courses. All right. You just have to register yourself and the registration is completely free. All right. And the link to register yourself is already mentioned in the description box. Shall we start? Are you all ready? Yes or no? Please give me some love and affection. Please tell me that you are physically, mentally and emotionally present in the session. Shall we start? Naruto, well done. Good, good, good. Keep it up, guys. Let us start with the first question, which is on your screen. First, you try to solve the question on your own and I am there to help you out. Good morning, Pawan. Welcome. Those who have joined me lately, this is the first question on your screen from the viscosity property. There are two properties which are very, very important in your fluid mechanics. One is the viscosity, another one is the surface tension. Yes? Can you solve it? So the question from the viscosity are always solved by using the Newton's law of viscosity. According to Newton's law of viscosity, shear stress is directly proportional to rate of angular deformation, or we can also call it as velocity gradient. The shear stress is directly proportional. The shear stress developed is directly proportional to rate of angular deformation or velocity gradient. In equation form, we need to insert a constant of proportionality. The constant of proportionality is called as coefficient of viscosity. This is the mathematical expression or equation form for Newton's law of viscosity. Mu is known as, what is mu? Mu can be called as dynamic viscosity. Why it is called as dynamic viscosity? Because it gives the information about the shear stress requirement, or indirectly it is giving us the information about the shear force required for the angular deformation or for unit rate of angular deformation. It is also known as absolute viscosity. Why it is called as absolute viscosity? Because mu is independent of density of the fluid, or we can also call it as coefficient of viscosity. So the question will be solved by using this formula. Velocity profile is given to you. You have to find out the shear stress at y is equal to 10 mm. Waiting for your answer, guys. What is the unit of viscosity? Unit of viscosity, SI unit is Pascal second or Newton second per meter square, or we can call it as kg per meter second. And this is SI or MKS unit, or the CGS unit is Dyn second per centimeter square, or we can call it as gram per centimeter second, or we can call it as poise. You should memorize the units of the coefficient of viscosity. What is the answer? Vinod is saying D, Naruto is saying C. And 1 Pascal second or 1 poise is equal to 0.1 Pascal second. This is the conversion. This is the conversion. All right. Can you solve it? I want everyone to respond. If the velocity profile would have been linear, for linear velocity profile, I am giving you the related concept. If the velocity profile is assumed to be linear, du by dy will be replaced by v by h. Du by dy will be replaced by v by h. So the expression for Newton's law of viscosity will become tau is equal to tangential force per unit shear area, which is mu into v by h. It remains constant. It is not a function of y. For linear velocity profile, tau will remain same at each and every location. Yes, the right answer to the given question is option D. What you need to do is, let us first solve this question. What you need to do is, you need to find out the value of du by dy. Du by dy is 2 minus 6y square, then plus 4y cube. Do you agree? Du by dy, differentiate this, then it will give you 2 minus 6y square plus 4y cube. And at y is equal to 10 mm means 0.01. Y is equal to 0.01 meter. So if you take square of 0.01, it will be very small. If you take cube of 0.01, it will be very small. So du by dy, what we can say, du by dy at y is equal to 0.01 is almost 2 second inverse. It is almost 2. We can round off the calculation by ignoring the value of y square and y cube. Do you agree? So it is almost 2. And if you multiply by the viscosity, it is given as 1 centipoise. It is given as centipoise. 1 centipoise is 10 to the power 1 centipoise is equal to 10 to the power minus 2 poise, and that is equal to 10 to the power minus 3 Pascal second. So 2 multiplied by 10 to the power minus 3 will be your answer. 2 into 10 to the power minus 3 will give you the answer. I hope this is clear to everyone. Is the question clear? Yes or no? Vinod, Anonymous, well done guys. Vinay, well done. Naruto, did you understand your mistake? Hi exam chunk, welcome. How are you? So let us continue our discussion for the related theory or the related formula, right? This is for linear velocity profile. And there is another parameter defined nu, that is mu by rho. That is called as kinematic viscosity. SI unit is meter square per second. That is called as kinematic viscosity. What is the difference between dynamic viscosity and kinematic viscosity? Because kinematic viscosity gives us the information about the momentum transfer ability. Good morning, Bisati, Srinu, welcome. So kinematic viscosity is inversely proportional to density. Kinematic viscosity will be inversely proportional to density. And there is another unit of kinematic viscosity that is called as centimeter square per second or stock. And 1 stock is equal to 10 to the power minus 4 meter square per second. Convergence you should always know. Sometimes they do not mention whether it is dynamic viscosity or kinematic viscosity in the question. If nothing is mentioned about the dynamic or kinematic viscosity, then how do you find it out? From the unit. Check the unit. If the unit is Pascal second, Newton second per meter square, kg per meter second, or poise, centipoise, gram per centimeter second, or dyne second per centimeter square, then it is definitely dynamic viscosity mu. But if the unit is meter square per second or centimeter square per second, stock, centistock, millistock, etc., then it is the kinematic viscosity given in the question, right? And the viscosity depends on temperature. Like any other property, viscosity of the fluid always depends on temperature. How viscosity depends on temperature? Can you let me know? If the temperature increases, what happens to viscosity? Every one of you. If we increase the temperature, what happens to viscosity of the fluid? I for increase, D for decrease. Everyone. I invite all of you to share your knowledge. As the temperature increases, what happens to viscosity? Will it increase or decrease? Your answer should be, if we talk about the liquid, viscosity decreases because cohesive force is governing the viscosity. In liquid, by increasing the temperature, cohesive force decreases. Yes? And if we talk about the gas, then by increasing the temperature, viscosity of the gas increases, because in a case of a gas, the governing parameter is molecular momentum transfer or molecular collision. By increasing the temperature, molecular collision increases or molecular momentum transfer increases. That is why it will increase the viscosity of the fluid, of the gas, right? Yes, well done. For air it will increase, for water it will decrease. Good, good, good. For liquid it will decrease, for gases it will increase. Aspirant, welcome. Molecular momentum transfer. Can you get me the exact expression for a gas? Dynamic viscosity of a gas is proportional to T to the power 1 by 2, where T is the absolute temperature. T will be the absolute temperature. And the kinematic viscosity of a gas is proportional to T to the power 3 by 2. Right? You should know, remember the values also. Dynamic viscosity of water is 10 to the power minus 3 Pascal second. Dynamic viscosity of water is 10 to the power minus 3. And kinematic viscosity of water is 10 to the power minus 6 meter square per second. Let us move to the next one. I hope this is clear. The next question on your screen. First, try to solve this question and then I will discuss the theory or the concept or the revision of the formula. So my class will be such that there will be a question, we will discuss the question, and at the same time we will discuss the related concept to that particular question. Yes, there is a question on the screen. Every one of you, please get me the answer. The question is from the capillarity, and capillarity effect is due to surface tension. I told you surface tension and viscosity are the two most important properties. Yes, then we will move to the statics of the fluid. Assuming that sap in the trees have the same characteristics as that of water, and that it rises purely due to capillary phenomena, and capillary phenomena is because of the surface tension, the relative magnitude of cohesive force and adhesive force. Cohesive force acts between similar molecules and adhesive force acts between dissimilar molecules. What will be the average diameter of the capillary tube in the tree if the sap is carried to a height of 10 meter? Take the surface tension of water as 0.0735 Newton per meter. This is 0. Yes. Who will be the first? Do not use the calculator. You are not allowed to use the calculator. Even if you are not getting the correct answer, do not get yourself demotivated, because an expert in anything was once a beginner. So even if you are getting incorrect answer repeatedly, do not lose hope. Try to work hard. Try to improve your fundamentals, the weak areas. Work on your weak areas. The improvement is just a gradual process. It never happens overnight. But what is important is your participation. Accept your mistakes. Try to be open to commit as many mistakes as possible, so that you will learn from your own mistakes and you are not going to repeat in your final examination, right? Yes, the answer to this question is option A. If you see three options A, B, C, they will be looking quite similar to each other. Answer to this question is option A. Vinod, well done. Vinay, I was not talking to you. मैं आपसे नहीं बोल रहा था. I was saying in general, because we are quite habitual of using the luxury or using the devices or smart devices to keep our life simple, to make our life simple. So students are so much, even I am very much habitual of doing even the simple calculation using the calculator. So because ISRO will not allow you to use the calculator, so practice yourself that way. Make up your mind that you are supposed to do even the tougher calculation, complicated calculation, without using the calculator. Try to make the calculation simple. Try to make the values round off so that your calculation becomes simple. Yes. So the rise of capillary or fall of capillary is given by 4 sigma cos theta upon rho of liquid into G into D. This is the formula. If we are getting it as positive, then there will be a capillary rise. If we are getting H as negative, then there will be a capillary fall, right? This is the formula for capillarity. I hope this is clear. Because theta is not given and theta is almost 0 degree for pure water. For water, yes, exam chunk. Theta is almost 0 degrees. So cos theta is almost 1. So D is equal to 4 sigma upon rho of liquid into G. So what is the value? 4 into 0.0735 upon density of water is 1000 into, let us take G as 10. This will be meter. If you convert it into millimeter, then diameter will be, if you convert, this will give you the answer in meter. The diameter will be equal to multiply with 1000. So it will be 4 into 0.00735, isn't it? Millimeter. And if you do the calculation, your answer will be close to 0.003. It will be 0.009 something, 29. क्या मैंने सही लिखा है? Did I commit any mistake? H तो लिखा नहीं मैंने, H तो लिखा नहीं, into 10. So it will become in millimeter, it will become 4 into 0.000735. Do not commit the mistake which I had committed, right? So you will get your answer to be like this. Now, theta will be going to decide whether H will be positive or negative. It is always theta. Theta is, if theta is less than 90 degree, when cohesive force, let me write it CF, when the cohesive force is less than adhesive force, then theta will be less than 90 degree and H will be negative. Cos theta will be negative. For theta less than 90 degree, for theta less than 90 degree, cos theta will be positive, and theta will be greater than 90 degree if cohesive force is greater than adhesive force. Then cos theta will be less than 0, right? So theta is called as contact angle. We call theta to be contact angle. Let us revise the concept of surface tension as well. Sigma is equal to surface tension force per unit length of the common interface. That is Newton per meter. That is called as surface tension. It all depends on the relative magnitude of cohesion and adhesion. Or we can also call it as the amount of work required per unit change in surface area of the liquid. Because the surface tension minimizes the surface area. So the unit can also be called as joule per meter square. And if we use the applications of surface tension, one is pressure in a liquid drop in excess to outside pressure. What is the formula? Pressure in a liquid drop in excess to outside pressure, 4 sigma by diameter, or that is same as delta P for an air bubble. Do not forget, air bubble and liquid drop are having the same formula, 4 sigma by D. Then delta P for a soap bubble, because soap bubble is having two interfaces, it is given by 8 sigma by D. And for liquid jet, pressure difference across the liquid jet inside and outside is equal to 2 sigma by diameter of the jet. And sigma as usual is a function of temperature. If we increase the temperature, cohesive force decreases, isn't it? So that is why the surface tension also decreases. And surface tension for water and air interface, what is the value? Surface tension, if it is mentioned at water, it is shared by two fluids. One of them is water, another is air. 0.0736 Newton per meter or joule per meter square. Newton per meter or joule per meter square, 0.0736. Right? This is about the surface tension. All right. So let us proceed further. I hope you guys are aware. What angle, exam chunk? Which angle you are talking about? Acha, for water it is around 22 degree. For pure water it is almost 0 degree. And for mercury it will be 132 degree. Contact angle you are talking about, right? For mercury the contact angle is around 132 degree, which is greater than 90. So cos theta will be negative. There will be a capillary fall in case of mercury, in case of glass tube kept in a mercury. Similarly, for water, the contact angle is 22 degree, which is less than 90 degrees. So H will be positive. So there will be a capillary rise when a glass tube is inserted in water. And if it is pure water, then the contact angle will almost be So for theta to be less than 90 degree, the meniscus will be concave. For theta greater than 90 degree, the meniscus will be convex, right? So there is another series which is running on our BYJU'S YouTube channel, that is 50 mark series for GATE 2024 aspirants. Right? I hope you guys are already aware the series has already been started from 3rd of July, and this is the course which we are running from a couple of days back only. The session you are watching is through this ISRO 2023 crash course. Every Monday, Wednesday and Friday there will be a technical session for ISRO 2023, and on Saturday or Sunday there will be an aptitude session. This is the schedule for this week. For the next week we will share the schedule very soon. So today I am discussing fluid mechanics, statics and kinematics, and on 21st again, day after tomorrow again, I will discuss fluid dynamics. All right. Next question, let us move to our manometry. Please find the answer to this. हाँ एग्जाम चल. When cohesive force is less than adhesive force, the liquid is called as wetting liquid. When cohesive force is more than adhesive force, when cohesive force is less than adhesive force, it is called as wetting liquid. When cohesive force is greater than adhesive force, it is called as non-wetting liquid. What is the answer to this question? This is very simple. C is the answer. So whenever we talk about the manometry, we should understand two concepts. One is called as Pascal law. It is applied to a static fluid. According to Pascal law, pressure is not a function of x and y, remains constant in a horizontal plane. According to Pascal law, any 2 points at the same elevation, same height, in the continuous mass of same static fluid will always be at the same pressure. So in case of continuous mass of same static fluid, if the 2 points are joined by the same fluid, same static fluid, and the points are lying in the same horizontal plane, then they will definitely have same pressure. And the second one is hydrostatic law. Hydrostatic law is about the vertical plane. According to hydrostatic law, pressure as a function of Z. It is about the pressure variation in case of vertical plane. Pascal law is about a horizontal plane, and hydrostatic law is about a vertical plane. So dP by dZ is equal to plus minus rho into G. This is the expression. And in case of compressible fluid, the variation of pressure is exponential, whereas in case of incompressible fluid, the variation of pressure is linear. The pressure increases linearly with depth in case of static single fluid, and the pressure decreases linearly with height if the fluid is incompressible. Whereas if the fluid is compressible, the variation of this pressure with height or depth is exponential. Z is the vertical distance from a reference. It can be depth or it can be height. Pressure decreases with height, pressure increases with depth. So P is given by rho fluid into G into H. This is how we can find out the pressure, and we can say pressure is directly proportional to H because the fluid is same, acceleration due to gravity is constant, so pressure is directly proportional to H. So PA upon PB. What is H? H is the depth from the free surface. Depth from free surface. So pressure is PA by PB is equal to HA by HB. Find out the value, the ratio of pressure between the 2 points A and B located respectively at the depth of 0.5 upon 2 meter. So it will be 1 by 4. Very simple question. Yes, Naruto. Well done. Pawan, Vinod, Vinay, everyone. Those who are not responding, it means you are not open to learn. Those who are not ready to commit mistake, that means they are not ready to have the improvement in their life. As simple as that. The more you commit the mistakes, the more open you are to improve yourself. The next question is regarding the pressure equation using the Pascal law and hydrostatic law. There are two methods. One is called as datum line method and another is called as jumping method. Can you solve this question? Every one of you, please give it a try. The absolute pressure, we need to find out the absolute pressure at point A in the figure given if the atmospheric pressure is to be taken as 101.3 kilonewton per meter square, or we can call it as kilopascal. There is a relation between absolute pressure and gauge pressure. Do you know that absolute pressure at any point is sum of atmospheric pressure at that point? It means the local atmospheric pressure plus gauge pressure at that particular point. This is the relation. And the gauge pressure can be positive or negative. And negative gauge pressure is known as vacuum pressure. Are you guys solving it? There is a manometer, U2 manometer attached. There is a manometer attached. And one limb of the manometer is attached to the pipe where the water is flowing, and another limb of the manometer is open to the atmosphere. Yes, Janki Raman, atmospheric pressure, but atmospheric pressure should always be local one. Atmospheric pressure should be local and the gauge pressure should always be used with sign. These are the two important things which you should always remember whenever we use this expression. Plus the third important point is all the pressures should have the same unit. There are so many units of pressure. One is Pascal, another is bar, 10 to the power 5 Pascal. Another is kgf per centimeter square, that is 9.81 upon 10 to the power minus 4 Newton per meter square or Pascal. There is another unit, pressure head, H, which is P by rho G. This is the pressure head. Another unit is torr. One torr is 1 millimeter of mercury head. So many units are there. Another unit is atmosphere. 1 atmosphere is 1.013 bar. Or we can say 1.013 into 10 to the power 5 Pascal. So there are various units of pressure. You should be able to convert them into each other. Yes, can you solve it? So start from point A. We assume the pressure at A as PA. Let me use the writing the pressure equation PA. Here the pressure is PA, which is unknown. If we are traveling in downward direction, pressure increases with depth. Pressure will increase with depth plus. So the sign will be plus. We are traveling in water. So density of water into G into how much distance we are traveling in water? 0.5 plus 0.2, that is 0.7. Now from here we can jump to this point. That method will be called as jumping method. And or the pressure at these 2 points will be equal. X and Y will have same pressure. So this line is called as datum line. Then the method will be called as datum line method. So the condition here or the concept here is X and Y will always have the same pressure because these are the 2 points which are lying in the same horizontal plane joined by the continuous mass of single static fluid from the bottom. Right? So if we jump, let me jump. So there is no change in pressure. Here we are here now in the right limb. Now from here we are traveling in upward direction. So minus. Now we are traveling in carbon tetrachloride having the specific gravity as relative density is 1.6. 1.6 into density of water, that is the density of carbon tetrachloride, into G into how much distance we are traveling, 0.2, is equal to, we have reached to our destination, that is PATM. If we are considering PATM, then we will get the absolute pressure. So PA absolute is equal to atmospheric pressure in kilopascal. It is 101.3 kilopascal. Then you will send this plus 1.6, if we convert it into kilopascal, 10 into 0.2, then minus density of water divided by 1000, 1 into 10 into 0.7. This will be your answer in kilopascal. So 101.3, then plus how much is that? 1.6 into 2, 3.2, minus 10 into 0.7, that is 7. So 101.3 minus 10.2. So it is something, it is less than, it will be less than 101.3. 105 is not possible. Negative values will not be possible. 3.73 is very less. It is option D. It is option D. We know the aspirant. The answer will be option D. Are you getting it? The answer will be option D to this question. I have taken G as 10. That is why my answer will not exactly match, but you can find out the nearest option. In ISRO, because the questions will all be MCQs, so even if you do not do the exact calculation, even if you get the answer which is nearest to your actual answer, then also you can select the right option, isn't it? 97.57 kilonewton per meter square or kilopascal will be the answer. The next is from the hydrostatic force. The next question, try to solve the next one. The question is saying hydrostatic pressure, but the answer should be in kilonewton. It means it is the hydrostatic force actually. It is not the pressure, it will be hydrostatic force exerted on one side of an annular area which is enclosed by concentric circles of radii 2 meter and 1 meter and having its centroid 4 meter below the free surface of water. This is the annular plate, this is the centroid, and this is, let us say, free surface. The depth of the centroid from the free surface of water is 4 meter. What is this 4 meter? Can we call it as x bar? X bar is 4 meter. X bar will be the value of 4 meter. I use the formula. It is a vertical plane surface. For any surface, any plane surface, F is given by rho of fluid into G into area of the plane surface into x bar. X bar, what is x bar? X bar is depth of centroid. I am using the notation G. Depth of centroid of the plane surface measured from the free surface. Depth of the centroid of the plane surface which is measured from the free surface of liquid. That is important. So x bar is already given as 4 meter. If you put the values, F is given by you. The question is to find out the hydrostatic force. Rho, that is 10 to the power 3 into G, let me take as 10 into area. What is the area? It is pi by 4, then D square, D1 square, 2 square minus D2 square. This is the area. Because it is annular circular plate, area will be pi by 4 into D1 square minus D2 square into x bar, that is 4. It will be in Newton. If we want to have it in kilonewton, then pi by 4 into 10 into 4 minus 1, that is 3 into 4. अरे क्या हुआ? Rho G AX bar. Rho into G into area 4 minus 1 3 pi by 4 D1 square minus D2 square. Acha, I am committing the mistake to make you aware about these. It is radius which is given. It is not area which is given. Pi r square. It will not be 4 in the denominator. Radius are given as 2 meter and 1 meter. Do not commit this mistake. Sometimes radius are given, sometimes diameters are given. You should always be clear with that. 10 into pi into 3 into 4. That is 120 pi kilonewton is the value of F. So option A is the correct answer. It is option A which is the right answer to this one. A will be the right answer. Yes, Naruto, Vinay, Pawan, well done. Good, good, aspirant. I hope this is clear. So in case of plane surface, the formula for F will be same. Even if it is inclined plane surface or horizontal plane surface, we will be going to use the same formula for calculating the hydrostatic force acting on one side. The only change will be to calculate the value of x bar. X bar is always measured in vertical direction. What is x bar? X bar is the depth of centroid of the plane surface. Whether it is inclined, horizontal, in vertical does not matter. Depth of the centroid of the plane surface measured from the free surface of the liquid. If you will not commit in mistake in the calculation of x bar, then you will not commit any mistake in the final answer. Yes. The next question on your screen. Can you solve the next two questions? Every one of you, please give it a try. हाँ विनोद, कुछ कहना चाह रहे हैं? Yes, please do solve this. If you will not practice, then someone else will become better than you. It is a relative competition. So the more you practice, you will be ahead of your competitors. So the competition is cutthroat. So many students are aspiring to be part of ISRO because ISRO always make us feel proud. It is the privilege for every engineer to become part of our space program, because ISRO is doing great, is making us feel proud at world stage. So this is the golden opportunity. You should not leave a single stone unturned to clear this examination, and we are there to help you out in every possible way. Whatever the type of session you want from our side, please do share your opinion, and we will definitely bring those type of session for your benefits. Provided you should involve yourself to the fullest, because your involvement motivates us to bring the sessions, bring more beautiful, more important, more fruitful sessions for you. What is the answer to this question? It is very simple. The only thing is you need to, whenever we are talking about the movement, then there is a point called as center of pressure. There is a point called as center of pressure. What is the center of pressure? Center of pressure is the point where the hydrostatic force is supposed to be applied. So many students commit mistake in calculating the center of pressure. So the question says there is a vertical plane, metal gates of size 3 meter by 3 meter. This is 3 meter. This is also 3 meter. Holds water on one side up to its top. The free surface is in contact with the top. Now the moment of hydrostatic thrust on gate about its top edge is. So G is different. G will be X bar. That is 1.5 meter. But whenever we take the moment, we need to calculate the location of center of pressure, where the hydrostatic force is actually acting, and this is called as depth of Cp. How to calculate depth of Cp? by using the pressure prism. You can find it out by using the pressure prism, isn't it? If you draw the pressure prism, it will be a triangle, and the centroid of the pressure prism will represent the location of central pressure. So can we say HCP is equal to 2 by 3 into 6? That is 2 meter. The depth of CP will be 2 meter. So if we find out the moment about the top, then the distance will be HCP. That is hydrostatic force multiplied by HCP. What is hydrostatic force? That is rho of water, the fluid is water, into G into area 3 into 3 into X bar. That is 1.5. This is the hydrostatic force into 2 meter will give you the value of moment about the top in Newton meter. Right? Clear? Am I clear to everyone? So what is the answer? If we want the answer in kilonewton meter, divide by 1000. So 10 into, this will also be 3 into 3 into 3 kilonewton meter. So it will be 270 kilonewton meter. The answer is option A. A will be the correct answer. A will be the right answer for this one. If we want to find out moment about the bottom, what is the value of moment about the bottom? Moment about the bottom will be equal to the hydrostatic force multiplied by 1 meter, 3 minus 2. That will be the moment about the bottom. Moment about the bottom will be F into 3 minus 2. What is the moment about G? F into, if you see the distance between G and CP, how much is that? G is 1.5 and CP is 2. So it will be 2 minus 1.5. This distance is 2 minus 1.5. Are you getting it? So whenever the question is about calculating the moment, then you should always find out the center of pressure. So let me write all the formula related to this for a plane surface. For a plane surface, if it is inclined plane surface, when the angle of inclination is theta. What is theta? Theta is the angle of inclined plane surface with horizontal. Theta is the angle with horizontal. Angle with the horizontal. Always remember, it is not angle with the vertical. So the value of hydrostatic force is given by rho of fluid into G into A into X bar. And the depth of CP is given by X bar plus Ig by A X bar sine square theta. This is the formula. Then if it is vertical plane surface, then theta will be 90 degree, isn't it? The formula for F will remain same. Then HCP theta becomes 90 degree, then sine theta will become 1. So it will be X bar plus Ig by AX bar. And if it is horizontal, if the plane surface is horizontal, if it is horizontal, then theta will be 0 degree because theta is always the angle with the horizontal. If the surface is already horizontal, then the formula for hydrostatic force will remain same. Then HCP will become X bar because sine 0 will become 0, right? And what is X bar here? Sorry, X bar we have already discussed. HCP we have already discussed, depth of central pressure from the free surface. And what is Ig? Where Ig is nothing but area moment of inertia. Area of moment of inertia of plane surface about its centroidal axis. About its centroidal axis. What is the centroidal axis? The axis which is passing through G and parallel to the base. Parallel to the base. You should be clear with Ig. For a rectangle, let me use another couple of slides. Just hold on. For a rectangle, what is IG? Can you let me know? For a rectangle, IG will be? For a rectangle, if the rectangle is kept like this is L, this is B. So IG will be equal to L into B cube by 12. If the rectangle is kept like this, or if the rectangle is kept like this, if this is L, this is B, this is G, then IG will be equal to B into L cube by 12. For a triangle, this is, let us say, H, this is B. For a triangle, IG will be equal to B into H cube by 36. For a circle of diameter D, IG will be equal to pi by 64 D to the power 4. And if it is an annular plate, so IG will be equal to pi by 64 capital D to the power 4 minus small d to the power 4. These are the values. All right. And if it is a curved surface, how to analyze the curved surface? How to analyze the curved surface? For a curved surface, the analysis of hydrostatic force will be done in two ways. If it is a curved surface, then what we will do to calculate the horizontal component, we will take the vertical projection. For horizontal component, take the vertical projection of the curved surface. And once the vertical projection is taken, apply the formula rho g a x bar. Vertical projection area is AVT. So FH will be equal to rho into G into vertical projection area of the curved surface into x bar. X bar is the depth of centroid of this vertical projection from the free surface, rho g a x bar. And the line of action of this FH will pass through CP for the vertical projection. It will act here only. It can be in positive x direction or it can be in negative x direction depending on the actual contact. But the line of action will pass through the CP for the vertical projection. And how to find out HCP? X bar plus IG by vertical projection area into x bar. And how to calculate the vertical force? To calculate the vertical force, what we are supposed to do is extend the edges normally up to free surface. Weight of the fluid which can be contained by the curve normally up to free surface. This is, let us say, volume V. So Fp, the magnitude of Fp will be equal to rho fluid into G into volume of the fluid which can be contained by the curve up to free surface. And it can be in downward direction or it can be in upward direction, will be decided by actual contact. If the fluid is in contact from the top, then the direction of Fp will be downward. If the fluid is in contact from the bottom, then the direction will be upward, right? So this is how, and the resultant force Fr will be equal to under root of Fh square plus Fp square. That is the resultant force, and the angle phi will be equal to, for the resultant force, the angle phi will be equal to tan inverse of Fp by Fh. So that is all about the hydrostatic forces. Let us proceed further. For the kinematics, let us proceed further. Yes, try to find out the answer for this one. The velocity component for a two-dimensional incompressible flow of a fluid are u is given, velocity in x direction and velocity in y direction is also given. It can be concluded that, so whether the flow satisfies the continuity equation or not, how to memorize the continuity equation? The general continuity equation, that is mass conservation equation. Continuity equation or mass conservation equation is given by del rho by del t plus del by del x rho into u plus del by del y rho into v plus del by del z rho into W is equal to 0. That is the continuity equation. And for incompressible flow, if the flow is incompressible, what is the meaning of incompressible flow? Density is neither a function of x nor y nor z nor time. Density remains constant. If the density remains constant, our expression, then the continuity equation will become del u by del x plus del v by del y plus del w by del z is equal to 0. That is the continuity equation for incompressible flow. So it does not satisfy continuity equation. If you find out del u by del x, del v by del y, this is incorrect. And how to find out whether the flow is rotational or irrotational? How to find out whether the flow is rotational or irrotational? Angular velocity about z axis is given by half into del v by del x minus del u by del y. Similarly, angular velocity and vorticity about z axis is twice of angular velocity about z axis. So please check if this is 0. For irrotational flow, angular velocity must be 0, or we can say vorticity, that is equal to del cross v, or we can call it as curl of v must be equal to 0. For irrotational flow, angular velocity of vorticity must be 0. If you solve this, then you will get the flow to be irrotational. The flow will be irrotational. Right? The next question, the next one on your screen, that is from the buoyancy and flotation. Buoyancy. So buoyant force is given by Archimedes principle. It is the weight of the fluid displaced by the body. Buoyant force is acting in upward direction, which is called as net vertical hydrostatic force, and it is always acting in upward direction, which is equal to weight of the fluid displaced by the body. It is not a function of density of the body immersed. Can you solve this question? And for vertical equilibrium, the buoyant force should be equal to weight. For vertical equilibrium, because weight is acting in downward direction and buoyant force is acting in upward direction. A block of wood floats in an oil with 90% of volume submerged. So the volume of the fluid displaced is 0.9 times of volume of the body. In another situation, it is floating in oil. In another situation, the same block is 67% of its volume submerged in water. What is the specific gravity of the wood and the oil? Wood means the body and the oil. Can you find out the answer? So can we say in first case, density of the oil, buoyant force by oil is equal to weight of the body, density of the oil into G into 90% of the volume of the body is equal to density of the body into G into volume of the body. Buoyant force must be equal to weight. In second case, buoyant force by water should be equal to weight of the body. What is the buoyant force by water? Density of water into G into 0.67 into volume of the body is equal to density of the body into G into volume of the body, weight. So if we find out the specific gravity of the body, which is the ratio of density of the body upon density of water, so how much is that? 0.67, isn't it? So the specific gravity of wood is 0.67. B, C, D cannot be possible. B, C and D cannot be possible. And to find out the specific gravity of the oil, what we can say, buoyant force by oil is equal to buoyant force by water. Why? Because it is equal to weight of the body for vertical equilibrium. For vertical equilibrium. Then what is the buoyant force by oil? Density of oil into G into 0.9 VB. What is buoyant force by water? Density of water into G into 0.67 into VB. isn't it? VB getting cancelled out, G and G getting cancelled out. So density of oil upon density of water is specific gravity of oil. That is equal to 0.67 upon 0.9, which is greater than 0.67. If you divide by 0.9, it will be greater than 0.67. The exact value is 0.74. That is for vertical equilibrium. And if we talk about the rotational equilibrium, for rotational equilibrium of a submerged body, how to check whether a submerged body is rotationally stable or not? BAG, center of buoyancy must lie above center of gravity or rotationally stable. The submerged body will be rotationally stable if center of buoyancy is lying above center of gravity. And if we talk about a floating body, for a floating body, what you need to memorize is, for a floating body, we should always remember MAG. Meta center must lie above center of gravity. If the meta center lies above center of gravity, then it is stable. Here M is called as meta center. And how to find out, or we can say BG or GM, or we can say GM should be, or we can say for rotationally stable, metacentric height should be greater than 0. What is GM? GM is equal to BM minus BG. And how to calculate BM? That is I minimum upon volume of fluid displaced minus BG. And how to find out BG? You can, B is the centroid of the displaced fluid and G is the centroid of the body. So we can find out this and can check whether the body, floating body, is rotationally stable, unstable or neutral. Right, so there is another series which is running on BYJU'S app, free series. You can join me today at 6 p.m. for mock tests. At 6 p.m. do join me on BYJU'S app. There will be 1 hour mock test for fluid mechanics, thermal and heat transfer today as well as tomorrow at 6 p.m. Right, the next question on the screen, ये तो हो चुका है. The next question on your screen. The area of a 2 meter long tapered duct decreases as given by this expression, where x is the distance in meter. At a given instant, the discharge is 0.5 meter cube per second, is flowing in the duct and is found to increase at the rate of 0.2 meter cube per second per second. This is the rate of increase of discharge. The local acceleration at x is equal to 0 will be. Can you solve it? The local acceleration, there are 2 types of acceleration. Is developed when the velocity is a function of time. And how to calculate the local acceleration? That is del Vx by del t. Or we can write Q is equal to area into velocity. So del by del t, Q upon Ax. Area is not a function of, that is local acceleration is given by 1 upon Ax into del Q by del t. Rate of change of discharge is given 1 upon 0.5 minus 0.2x into what is the rate of change of discharge, that is 0.2. This is local acceleration. This is the mathematical expression for local acceleration. Now if we want to find out the value at x is equal to 0. If we find out the value at x is equal to 0, then the local acceleration will be given by 0.2 divided by 0.5, that is 0.4. Answer is 0.4. And there is another acceleration which is known as convective acceleration. What is convective acceleration? It is developed when the velocity is a function of space. And how to write the expression for convective acceleration? Whenever the velocity changes with the space, is develop the convective acceleration. Vx into del Vx by del x. That is the formula. Put the value Vx by Q by Ax. Q upon Ax into del by del x, then Q upon Ax. Now here Q is not a function of x. So it is Q square upon Ax into del by del x 1 upon Ax 0.5 minus 0.2x. So expression will be Q square upon 0.5 minus 0.2x multiplied by, can you do the differentiation of this? So it will be minus 1 into 0.5 minus 0.2x to the power minus 2 into minus 0.2. This will be the expression. So expression will be Q square upon 0.5 minus 0.2x to the power 3. Then it will be 0.2. That is the expression for convective acceleration. And if we want to find out the value at x is equal to 0, can you find out the value at x is equal to 0? What is the convective acceleration at x is equal to 0? At x is equal to 0, what will be the convective acceleration? What is Q? The value of Q? The value of Q is 0.5. So it will be 0.5 square into 0.2 divided by 0.5 cube. Isn't it? At x is equal to 0, put x is equal to 0. So this square will get cancelled out. It is also 0.2 by 0.5, that is 0.4. Convective acceleration will also be 0.4. Local will be 0.4, convective will be 0.4. If we write in 3D system, for 3D flow, then there is a acceleration in x direction, local acceleration del u by del t plus u into del u by del x plus v into del u by del y plus w into del u by del z. Local plus convective. Similarly, acceleration in y direction del v by del t plus u into del v by del x plus v into del v by del y plus w into del v by del z, and az will be del w by del t plus u into del w by del x plus v into del w by del y plus w into del w by del z. These are, and the magnitude of total acceleration is under root of ax square plus ay square plus az square, and the acceleration vector is ax I cap plus ay j cap plus az k cap. This is how you can find out the acceleration. The next question, can you solve the next one? This is the last question. Solve this one. The streamline equation passing through the point 2, 3 will be, we need to find out the equation of the streamline. First of all, develop the differential equation of a streamline. This is second last question actually. dx by u is equal to dy by v is equal to dz by w. That is the differential equation of the streamline, where the velocity vector is given by u I cap plus v j cap plus w k cap. What is the answer? Because it is 2D flow, so we can say dy by dx is equal to v by u. What is v? A. What is u? This is also a, so that is 1. So dy is equal to dx. If we integrate this, then we will get ln y is equal to ln x plus constant, we can call it as ln c. So y is equal to cx is the equation, but we need to find out the value of c at 2, 3. At 2, 3, what is the value of c? Y is equal to 3, x is equal to 2. sorry, it is not. Did I make any mistake? Integration of dy is y. Integration of dx is x plus c, isn't it? This is our expression. And at y is equal to 3 and x is equal to 2, c is equal to 1. So if we put the value, then our expression is y is equal to x plus 1. This is the equation of the streamline. Y is equal to x plus 1. B is the answer. Yes, it will not be log. It will not be ln. Well done. Good, good, good. Right? One more question from the stream function and velocity potential function. What you need to remember is u is given by minus del phi by del x, that is del psi by del y, and v is equal to minus of del phi by del y, that is equal to minus of del psi by del x. If you remember these, then most of the question will get solved. The stream function in a 2D flow is given by this expression. Then the magnitude of velocity at point 1, 1. Find out the value of u and v. What is u? That is del psi by del y. What is del psi by del y? Minus 2y. And at 1, 1, it will be minus 2 into 1. What is v? Minus del psi by del x. And that is minus 2x. At 1, 1, that is minus 2 into 1. So the magnitude of velocity is given by under root of u square plus v square. That is under root of minus 2 square plus minus 2 square. Root 4. 4 plus 4. Under root 16. Under root 8. 4 root 2. 4 into 2. 2 root 2 is the answer. B is the answer. B will be the correct answer. Can you find out the corresponding velocity potential function? Phi as a function of x and y. Can you find out the corresponding velocity potential function? Because phi is a function of x and y, we can say d phi is equal to del phi by del x into dx plus del phi by del y into dy. And what is del phi by del x? We can write it as minus del psi by del y into dx plus what is del phi by del y? Del phi by del y, that is del psi by del x into dy. So put the value del phi by del psi by del y minus 2y. So it will be 2y minus 2y into dx plus del psi by del x. What is del psi by del x? That is 2x. This is 2x into dy. If we integrate this, then phi will be equal to 2yx plus 2xy. So it will be 4xy. That will be the answer. Phi will be given by 4xy. Phi will be given by 4xy. Isn't it? It is minus will become plus. We know it will become plus 2xy plus 2xy. So 4xy will be the answer. I hope this is clear. So that is all about the statics and kinematics important formula. So on 21st, we will be meeting again at 11 a.m. This is your assignment question. Try to solve this question. This is wonderful question. Try to solve and get me the answer. Either through the Telegram group or even if you are part of any of the WhatsApp group, you can connect with me through that. All right. It is in two parts, question number 1 and question number 2. So thank you guys for joining in. I hope you guys have enjoyed the session. Do not forget to like this session and share this session so that it reaches to all the other students who are preparing for ISRO 2023. All right. So I thoroughly enjoyed it. I hope you Also got the revision of the concept of statics and kinematics. I hope this session was fruitful and helped you to improve your concepts. So there are some series which are running super Saturdays to make your learning more interesting and fun. There are series Sunday Ka Funda and Super Saturdays. Every Saturday and every Sunday we bring these type of session. All right. So that is all from my side. Let me take your leave now. See you at 6 p.m. today itself on the BYJU'S app for the practice session, and on 21st on YouTube at 11 a.m. Till then, enjoy, take care, have a good day and a great career ahead. Thank you and Jai Hind.